Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be going over how to apply radioactive decay kinetics to this particular problem. So this one's a little bit tricky. In this problem we have a meteor that contains 0.556 grams of lead 206 for every 1 gram of uranium 238. So if we assume that the meteor did not contain any lead whatsoever, or lead 206 to be exact, at the time of its formation, determine the age of the meteor. Okay, so we need to determine the age of the meteor. We know that it right now contains 0.556 grams of lead 206. We're assuming that there was no lead 206 to begin with. We're also given the information that uranium 238 decays into lead 206 with a half-life of 4.5 billion years. So we have for every 1 gram of uranium 238. So the decay that we're looking at is uranium 238 going to lead 206. So if we're to assume that in the beginning there was no lead 206 to begin with, then where did that lead 206 come from the beginning? It had to come from uranium 238. So we know right now we have 1 gram of uranium 238. So that's at time t, after how many years this asteroid has been around. And so we need to figure out, well, what was the original amount of the uranium 238? Well, the original amount includes whatever was lost during the decay process to form this amount of lead. So if we can work backwards from the grams of lead 206 back to the uranium 238 that from which it came, then we can add that original amount to the 1 gram, and then we'll have the original amount that we started with. Okay, so right now at NT, so our amount at time t right now of the uranium 238 is 1.00 grams. That's the amount that we have at time t right now, the whatever the age of the meteor is. Now, the initial amount is going to be equal to 1.00 grams of the uranium that we have now, plus the amount that came from the amount of the amount of uranium 238 that was used to produce this amount of lead 206. So if we do our conversion, we could take the 0.556 grams of PB206 and then convert that to uranium that from which it came. So we need the molar mass of PB206. So if we look that up, it's 206, so 200 grams per mole. So we know that because this particular isotope has a mass of 206. So you don't need to look on the periodic table for that because this particular isotope has that mass. Remember, the mass on the periodic table is an average of all of the isotopes, but we're not interested in the average of all isotopes. We're interested in this particular isotope here. So since it has a mass of 206, then it's 206 grams per mole. So we're going to put 206 grams of the PB 206, and then on the top we're going to put 1 mole of PB 206, And then we're going to multiply by our next conversion factor. I'll bring it down here for lack of space. So grams of lead 206 cancel out. Now I have moles of 206. So the mole ratio between uranium 238 and lead 206 is 1 to 1. For every atom that decays, the atom of uranium 238 that decays, it decays into one lead 206 atom. So therefore, it's a 1 to 1. So if I do a conversion, let me bring this over. So I have 1 mole of Pb 206 for every 1 mole of uranium 238. Again, I'm multiplying here. I'm continuing the conversion factor. So moles of lead 230, lead 206 cancel with moles of lead 206 here. And now that I have moles of lead 206, I can now multiply that by the molar mass of uranium 238. So I have moles of uranium 238. So 1 mole of uranium 238 on the bottom. And then, of course, because this particular isotope has a mass number of 238, then the mass of 1 mole is 238 grams of U238. So moles of U238 cancel out. Now I can multiply across the top, divide by what's on the bottom, and when I do that, I get grams of U238, and the number of grams are 0.6424. 0.6424 grams of uranium 238. So what does this mean? This means that this is the amount of uranium 238 that decayed to produce this many grams of lead 206. So this is part of the original amount that we started with. Right now, what we have left is 1 gram. So this is the amount that decayed. So the original amount is going to be the 1 gram plus this amount here. So let me move this down here so I have room. So the initial amount of uranium 238 is 1.00 grams that I still have, plus the amount that decayed. So 0.6424 grams. And so that total amount is going to be 1.6424 grams. So I have the amount I have now at time t, the initial amount that I had. So I have these two, and I have the half-life. So the half-life, I'll just write it here, T1 half is equal to 4.5, right? 4.5 billion years. All right, so now I got everything set up. Now I just plug everything into my equation. So I can use this one or I can use this one. Since I have both of these, I'll just use this one and plug everything in. So I have NT, which is 1 gram, 1.0 gram. So I have 1.00 grams. And I have N naught, the initial amount, which is right here, 1.6424. So 1.6424 grams. And that's going to be equal to 1/2 raised to the power of T over the half-life. And the half-life is 4.5 billion years. So we'll put 4.5 times 10 to the 9 years. Okay, so let's double check. Yep. So here, now all I need to do is solve for t. So let me take care of this. So I'm going to calculate that in just a minute. And when I calculate that out, I get 0.6088. So 0.6088. Let's throw 6 in there. Okay, grams cancels out. So now this part is unitless. And that's going to be equal to 1/2 of raised to the power of t over the half-life, which is again 4.5 times 10 to the 9 years. So now all I do is, since I have this here as a exponent here as a power, I want to bring that down to the front. So I'm going to take the log of both sides. So I'm going to take the log of here. Let me give myself some room here. I don't need these anymore. So I'm going to take the log of 0.6088 on this side, 886, and then that's going to be equal to 1/2. Oops, the log of 1/2, sorry. That's going to be equal to the log of 1/2 raised to the power of t over 4.5 times 10 to the 9 years. So now that I have this in log, I can take the power and write it and multiply it in front. I can put it in front of the log here because that's one of the laws of logs. So I'm going to rewrite this up here. Let me so this is going to be the log, and I'm going to erase that. So we're going to have the log of 0.60886, and that's going to be equal to, and then I'm going to bring this here, so it's going to be t over 4.5 times 10 to the 9 years. So I bring that here as a power, bring that in front. Now I'm going to multiply that by the log of 1/2. So there's my log of 1/2. And now what I can do is I can divide both sides by the log of 1/2. Let me get rid of this. So I'm going to divide both sides by the log of 1/2. Multiply this by, or divide this by the log of 1/2. So this cancels out. Now if I do that calculation, let me do that really quick. So I'm going to have the log of that divided by the log of 1/2, and I get 0.7158. So this is 0.7158. 0.7158. And so that is equal to this. So T, which is the age of our meteor, divided by the half-life, which is 4.5 times 10 to the 9 years. Now all I need to do is multiply both sides by the half-life. So I'm going to multiply by 4.5 times 10 to the 9 years on this side. And then I'll multiply on this side too. So multiplied. So I'm going to, how do I write this? I don't have any room. So I'm going to multiply this times 4.5 times 10 to the 9 years. So this times this. And so then what I get at this point, again, let's make some room here. So this cancels out, and I'm left with T. So in this case, T, the age of the meteor, is going to be equal to these two multiplied together. And I'm going to do that right now, times 4.5 times 10 to the 9 equals, and I get, let's see, 3.2. Basically, I get 3.2 times 10 to the 9 years. So that, ladies and gentlemen, is the age of our meteor. I hope this was helpful. I hope you enjoyed this video. If you learned anything from this video and enjoyed it, then please, by all means, like the video, share it with your friends. Also, make sure you click that like button right there. And also, make sure you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. And also, finally, put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.